All right, so far we have talked about different elements and how we find our protons, neutrons, and electrons, okay? So this guy right here is about to be your best friend when it comes to isotopes and ions. All right, so everybody should have a periodic table or one near you. So with this, again, just to recap, the top number is our atomic number, which is our number of protons. Then we have our element symbol, our average atomic mass, and the element name. All right, so with this bottom number is our average atomic mass. That means that we are taking all of the different versions of that element, combining them to find what that overall average is. So if we look at carbon, for example, okay, on the periodic table, it says carbon 12, right? Do we see that? It says carbon 12. That's not saying that that's the only carbon. That's saying that this carbon is the one that occurs most in nature. That's why it gets a spot on the periodic table. Okay, but that doesn't mean there's not a carbon 14, there's not a carbon 20, there's not a carbon 12. So we have different variations of these elements, and those different variations are what are called isotopes. Okay? Everybody following so far? All right, so this is where your notes should be getting filled in. All right, so what is an isotope? So it is the average atomic mass, the average of all naturally occurring isotopes and their abundance in nature. Okay, so it's how much does it occur in nature. All right, so isotopes, atoms of the same element with different numbers of neutrons. Okay, meaning they have a different mass number, which means the size of my nucleus is the only thing that's really changing. Okay, so for example here, we have carbon 12 and carbon 14, right? Okay, so if I am looking, and this is what you can fill in on that box, all right? So my protons and my neutrons. All right, so how many protons does carbon 12 have?
12.
Not 12. Remember, we're looking at our atomic number for our protons. 6. Okay, so what about carbon 14? 6. Okay, same number of protons. But now, how many neutrons do I have? Okay, so in order to find my neutrons, how many do I have with carbon 12? 6. All right, but what about carbon 14? 8. Okay, so that's just showing that carbon 12 and carbon 14, they're both carbon. They just have a different number of neutrons. Okay, does that make sense? So where do we get our average atomic mass on the periodic table? Basically, we've taken all the different variations or the different isotopes of carbon, found their average, and that's what we put on there. So now, on the periodic table, it says that carbon is 12.0107, right? So carbon 12 accounts for like 98% of all carbon, all right? All carbon that's used, it's 98% of it is carbon 12, while only 2% of it is carbon 14. Okay, so carbon 14, does anybody know what that was actually used for? Has anybody ever heard of fossil dating? Carbon dating for fossils? That's carbon 14. So is that the same carbon that we are going to use? No. Okay, so do we see how we have the same, both of them are carbon, but they're different? Yes.
Are both of them on?
No. So, hold that thought.
Does nothing go under recall?
No. Well, what's on the board? If it's blank, it's blank.
Okay.
Okay, so how is it that carbon 12 is the one on the periodic table? Because this is what we have. So if we're looking at this, if 98% of it is carbon 12, that's where we get this 12 from. Okay? And this is what takes into account my 2%. So what we've done is we've taken these two numbers, the masses of these two different types of carbon, average them out, and that's what gets put on the periodic table. That's where we get our average atomic mass. Does that make sense? Are there any questions about that?
How do you find out the age? Like, how do you know that it's 8?
14. Yeah, 14 minus 6. All right, are we good with this?
Yes, ma'am.
Questions?
No, ma'am.
All right, I'm gonna erase it.
Yeah. Alright, that's
Good? All right, so what we want to know is how do we calculate our average atomic mass? So how did they get the average atomic mass for the periodic table? And what if we discovered a new element and we want to add it to the periodic table? How do we know what we're going to put? Okay, well, luckily for you guys, their scientists have already done that. Okay, so with any word problem that you've had in math, what do they always tell you to do first?
Figure out pieces that you need.
Figure out what you need, underline, highlight, pull out what? What you know, okay? No different approach here. So that's what we're gonna do. So we're gonna pull out the information that we're given. So for this one, suppose that there were 3 isotopes of magnesium. 78.7% of magnesium atoms exist as magnesium-24, 10.03% occur as magnesium-25, and 11.17% occur as magnesium-26. What is the average atomic mass of magnesium? So without looking at the periodic table, let's suppose that we don't have a periodic table in front of us, or maybe it's not on the periodic table yet. So we're going to have to figure that out for ourselves. So this is how we do it. So first, write what you know. Okay? So what we know is 78.7% of magnesium occurs as magnesium-24. 10.03% occurs as magnesium-25, and 11.17% occurs as magnesium-26. All right? So, in math, can we work with percentages?
Yes.
We can, but not easily. So what do we always do with percentages first?
Fraction. Turn into decimal.
Turn them into decimals. Very good. How do I do that?
Convert it to decimal.
Perfect. In order to get rid of these percentages, because I want to be able to work with these numbers, but I can't do that as a percentage. So in order to get rid of that percentage, I can move my decimal 2 places to the left. Okay? So I'm going to do that for each one.
Turn it to a fraction.
All right? So then that will give me 0.117, 0.103, and 0.787. And those are gone. Okay? Are we all good there? Good so far? All we've done is wrote out what we know and got rid of our percentages. Good? All right. So now I want to say, okay, what is my atomic mass for magnesium-24, 25, and 26 separately, so then I can average them out. All right? So what I'm going to do is I'm going to multiply these numbers by the percentage or how much it occurs in nature. Okay, so this percentage is the abundance in nature, while this is the mass. Okay, so I'm going to multiply that. All right, so when I multiply that, it gives me, you guys do the math for me. So
The first one's 18.8.
18.8? Exactly.
No, it's
Yeah,
repeating.
those are pretty.
All right, what is 25 times 0.1003? And it is important that you include those when you're multiplying.
2.5.
2.5 what?
0.75.
Oh, it has to be exact.
For this part, yeah. All right, 26 times 0.1117.
2.9042.
Okay, good. The last thing that we have to do here is add these together.
That's all.
That's it. So what do I get when I add those together?
24.2997.
24 point, what is it?
2997.
Okay, does everybody see how we got that answer? So, the way that we can check that, for the ones that are on the periodic table, if it tells you that it's one that's on the periodic table, go back to your periodic table and check. So, if we look at magnesium, it is 24.3050. Were we pretty close? Yeah, we were very close. Okay, so I know that that answer is probably right. So, if it's on the periodic table, you can check your answers. Are we good with this? Do we understand how we got this? Yes. Do we understand how we got this?
Is there no unit?
Oh, of course. Yeah, we understand. Get the number.
Atomic mass unit?
That's it. Atomic number, yeah. Multiply it. Yeah, convert. It's a fact.
All right. I'm going to give you guys just a second to take a picture of this, add it to your notes. It's just important that you guys understand how we're doing this because there are questions on your test that it's going to ask you to do it. Okay. All right, are we good? Can I erase it?
Not yet.
Not yet.
Good? So it's simple math. It's just knowing what to multiply and when to add. Are we good? Okay. Guys. All right, so three isotopes of argon occur in nature as argon 36, argon 38, and argon 40. Calculate the average atomic mass of argon to 2 decimal places given the following relative atomic masses. Okay, when it says relative atomic masses, that's basically saying that I'm going to use this exact percentage because it's going to give us a very, very accurate answer. So when you see relative atomic mass, you're going to see your percentages are in decimals because it's giving you the exact number, whereas the last one we didn't have that for our percentages. But do not get confused when you see a decimal here and a decimal here. Don't move the decimal place for this part. Okay? So what are we going to do first? Write down what I know. So what I know is 35.97 is argon
36.
Sorry, I wrote it backwards. Alright, so 0.337% is argon 35.97. 0.063% is argon 37.96, and 99.6% is argon 39.96. Guys. Alright, so I wrote down what I know. What do I do next?
Multiply.
Where I multiply?
Just move the decimal.
Huh? What'd you say?
Move the decimal.
Yes. For which part? I have decimal places in both parts. Which one do I move?
The one with the percentages.
The one with the percentages. The only reason we're moving a decimal is to get rid of that percentage. Okay? So don't move your decimal places here because that's an exact number. The reason we're moving them here is because we're trying to get rid of this percentage to be able to work with that number. All right? So that gives us 0.996,
Well, you have the extra 0
No.
on the second one.
0.0006. So 3. So I'm glad you said that because the zeros matter here. So when you move this decimal place to the left, if there's not a number there, you still have to move it 2 places. You just go ahead and fill it in with a 0. But if you don't, it's going to give you the wrong answer. So you have to make sure that you add the 0 when you move it. You still have to move it 2 places. And if there's not a number there, put a 0 there. Okay? Because it does change the number. Are we good here so far?
Yes.
What am I going to do next?
Multiply.
Multiply what?
The decimal, the new decimal times the AL.
Perfect. So I'm going to take this isotope of argon and multiply it by its percentage of abundance in nature, which I have moved to give me a number. A new number without the percentage. Okay.
The first one, do you want us to tell?
Anchorage. Yes. Hi. Okay. Okay, thank you. All right, thank you. All right, so somebody tell me my numbers here. So what is 35.97 times 0.00337%?
1, 2.
1212.
Okay, 0.1212
189.
189. All right, what about the second one?
0.02. 39. 148.
8.
That's it.
Okay. And then what about this last one?
39.
Okay.
0.8. 0016.
Guys, stop talking. All right, so now what do I do? Add. So, what does that give me?
39.94. 5. It just continues on.
Okay. All right. So then what am I going to do? It's argon, so it's an element on the periodic table. So what am I going to do? Huh? I'm going to check the periodic table to check my answer. So if I come over to argon, it is 39.948. Are we close? Yes, we are very close. Okay, so we can see that this number is a lot closer than our last one, and that's because we use the relative atomic masses. Okay? Is everybody good with this one? Before I erase it? Everybody good with this one?
Oh, hold on, let me take a photo of this.
Guys. Okay, good?
Yeah, we good now. All right.
Who said wait? Come on, friends. Okay, so we have one more type of example that we're going to go through, and just because it changes it slightly. So, suppose that a new element was discovered that exists as 3 natural isotopes. 20% of the atom has a mass of 284, 30% has a mass of 285, and the remainder has a mass of 289. So what do I do first?
Write down what we know.
Write out what I know. 20% is, we're going to call it element E. It has a mass of 284. 30% has a mass of 285. And the remainder is 289. So, I pulled out what I know, but I'm missing something. What am I missing? Yeah, but I'm saying that these are the 3 natural isotopes. So it accounts for 100%. So I have to figure out what my percentage is here, but I can do that by saying, okay, well, all of this accounts for 100% of this element. So this is 20%, this is 30%. So the remainder has to be 50. Because that has to add together to be 100, right? Okay, so we all understand how we got that? So what do I do now? What do I do? Make my percentage in decimal. How do I do it?
Move it over 2 times.
Move it to the left 2 times. That's now gone, and it gives me 0.20, 0.30, and 0.50. Now what do I do? Multiply what?
The 0.20 and
Yep, my masses by their percentage that I have transferred into a usable number. All right, what is that?
85.5. 56.8. And 144.5.
Now what do I do? Add them together. What is that?
286.8.
So this is my average atomic mass. And for this element that I will put on the periodic table, we're going to say it's element E. Okay? Because E's awesome. And this is the number that we would put on the periodic table with it. Are there any questions about that? Okay. Will you stop the recording?
you are.
Any questions?
No.